Today is all about threat intelligence and how this can be used to protect businesses and internet users in general. Today's session will highlight how cyber threat intelligence is used within an enterprise to protect resources. We are going to examine how the SOC team can be structured to improve security. And lastly, a demo of staging an ARP spoofing DOS attack on a LAN. Your task was to investigate other threat intelligence organizations. Some of the better-known ones you may have come across include the CTA, the U.S. Department of Homeland Security, the CTIIC, and the Financial Services Info Sharing and Analysis Center, and Intel 471. In our last lesson, we learned about the MITRE ATT&CK Framework. Now, the best way of staying ahead is to stage a continuous attack simulation in a safe environment, as we did in the demo using our virtual box. By doing this, you will be able to study the attack and adjust your security system to mitigate real-life threats. In an enterprise network, cybersecurity analysts currently look at the people, processes, and technologies, because these are the vulnerable parts of a business where intrusion is targeted. Continuously scanning the enterprise network and testing for weaknesses gives the team a good idea of what measures need to be put in place to improve the security in those areas and improve the entire security of the enterprise. Here's a sobering fact for you. Did you know a report from MITREingenuity.org states that 82% of enterprise breaches should have been stopped by existing security systems in place, but weren't. When MITRE ATT&CK or another similar framework is deployed properly in an enterprise network, it lays the foundation for how cybersecurity analysts should focus on their security system and configure it to be able to withstand an attack. This fact can't be overemphasized. Using an available cyber threat intelligence framework makes the company more threat-informed and puts them in a better position to form a defense strategy against attacks. Adopting threat intelligence like MITRE ATT&CK can help a company to identify their threat actor on their network simply by using a global IP management framework. Have a live update on threat actors in real-time operation, and be able to analyze the impact to the enterprise. Create room for growth and improvement among cybersecurity companies by creating a shared knowledge on threat intelligence. And strengthen weaknesses and increase defense strategies. Having a fully competent team in the Security Operations Center, SOC, means a company will be able to counter an attack and attain detection and analytical skills to be able to fully protect the network or system. Using threat intelligence and the MITRE ATT&CK framework, companies could improve their security by splitting their SOC into 3 teams to tackle different threat areas, as portrayed in this table. Basically, a blue team exists to defend. It's the red team's job to attack, and the purple team supports the process. The primary goal of setting up an SOC based on the 3 colored teams is to get safe and stay safe, to have a constant safety parameter around the enterprise network. It's time to look at an attack more closely. An ARP spoofing, also known as ARP poisoning, is a man-in-the-middle attack that allows attackers to intercept communication between network devices. In this demonstration, we'll take you through how to conduct ARP spoofing. We will show you how to send malicious falsified ARP, address resolution protocol messages, to a victim's computer on the same LAN. We'll also cover how to conduct a DOS attack on the same LAN. In this demo, we'll be going through ARP spoofing. Now, the reason for this demo is to show you the majority of the theoretical parts that have been covered over the recent lessons. In previous lessons, we went through the installment of Kali Linux. But in this lesson, we'll be actually carrying out an attack. We will be sending some spoof messages as an attacker to impersonate someone else on another system. Now, the way this attack actually works is we're able to spoof our IP address, and we can do a lot of things with this piece of software. So, in a nutshell, to remind you what exactly this is all about, this demo basically is intended to be an attack on a local area network. So what that means is the attacker has to be within the same IP subnet. This demo could be done in different ways, but for this session, I'm actually going to be focusing more on the ARP spoofing. Now, during the demo, we'll be talking more about different things like denial of service and man-in-the-middle attacks. And we will be carrying out the spoofing. We'll be able to see the vulnerabilities we have, and we will be verifying that we actually were able to spoof our IP address on the same local area network. So, not to prolong this, let us simply jump into the lab session. Okay, so for this demo in general, we're going to be working with 2 virtual machines. We're going to be working with a Kali Linux that we actually downloaded and installed earlier, and we'll be working with our Ubuntu virtual machine. So in a practical sense, we will be actually trying to exploit the Ubuntu virtual machine now. The idea behind this, after carrying out the attack, would be to verify that the attacker was actually able to carry out this spoof. Now, if you remember from our previous lessons, we talked about the ARP, and we went through analyzing an ARP on Wireshark. But this time around, we will actually be spoofing our IP to try to connect to another machine in the same local area network. So first of all, we simply need to start our Kali Linux. I'll put in my password and my username. Okay, so at the moment we have the Kali Linux started up. And before we carry out anything, we need to demonstrate how this works. First, we need to go into our virtual box and start up our Ubuntu virtual machine. Now, the reason we have to do this is we need to verify that there are no ARP entries on our Ubuntu. Now, if there are any, we'll clean up the app cache and delete every inch of the app request that has been sent to the machine so that we have no ARP entries. Then we can launch the attack and verify that it actually went through. Okay, so at this point, I'm going to jump straight into my Ubuntu as well and start it off by confirming our IP address on our Ubuntu. Okay, at the moment, we have our Ubuntu started up, and we need to log in and put in my password. So we're just going to give it a couple of minutes for the Ubuntu to start up properly. And then we can verify all of those details. So the first thing I'm going to do is going into the terminal, and I need to start a Wireshark capture. And the reason we're going to start up on Wireshark capture is because we want to see how the attack was carried out and what actually happened. So, over the course of this demo, I'll be showing you how to mitigate the attacks that we all went through. I'll be showing you preventative measures of things you could do on your system to prevent attacks such as this. Okay, but for now, we need to capture this attack. At a later stage, we can actually analyze the data captured on Wireshark, and we can analyze how it happened and what to do. Now, this will be good because when you actually see this particular example and you analyze the Wireshark capture, you would understand more deeply how this happened and how to mitigate things like this. So first of all, I would go into my terminal, and while in my terminal, I'm going to run a command that is ifconfig. This is to actually highlight my IP address. And this is my IP address. Now that I know it, I can check the cache just to be sure we don't have any other entries on this machine. I'm going to clear the screen. So I've cleared the screen and now I'm typing in ARP-VN. Now the V helps to display the total number of ARP entries on the ARP cache. So now we can actually see, at the moment, we just have one entry. And it's a communication from our machine to a different machine that has an IP address of 192.168.56.100. Now, the reason why we do this is at the end of the session, we'll be checking the entry again, and we should be able to see the spoof IP address that we had, that we injected through ARP spoofing. Okay, so make sure you keep this in mind, and we'll confirm this IP address at the end of the demo. I'm just going to clear this and clear. And the next step is for us to start up Wireshark capture. While on Ubuntu, to actually capture the attack from the perspective of the victim. We simply need to type out this command: sudo tcp dump-i enp0s3-s 0-warp.pcap. I'll explain to you exactly what the command is in a bit. The first command is a sudo, which actually elevates your privilege on the machine. And the second command is the tcp dump, which helps the capturing of TCP traffic that could be analyzed on Wireshark. And the next alphabet we have is the -i. Now the -i stands for a command to allow you to capture on a specific interface. We are actually going to capture on this interface, which is on the Ubuntu. Now, just to verify which interface this is the interface we use to connect to while on our virtual box. And you can see here, eventually we're capturing traffic on the loopback interface. And now we'll be using LO on this list, because the name of the interface we have on our Ubuntu is this. Now to move on with the interface, after the interface we have the -S. The -S command option specifies the length of snapshots for each packet, so you can limit the snap to the smallest number that will capture the particular information in which you're interested. So basically what that means is we want to capture the smallest amount. So the smallest amount we set this to is 0. So we're going to be starting from point 0 and working through to the highest amounts we can actually capture. Now we know we have the -W, and the -W command is basically used to write. So we're just trying to see on the command line. I'm a super user, which means I have the privileged startup TCP dump that should capture traffic on this interface, and now sets the default snap of capture to 0, and writes this file, or rather writes this capture to this file, apr.pcip. So at the end of the writer's capture, we have the name of the file we want to actually save on the capture. So basically, that's all the commands we have on the command line. And now we can do the same thing by going into the GUI and looking at Wireshark and clicking on it. This is actually a much easier way for you to get familiar with capturing traffic while on the terminal. So it takes you a little time to run this command and searching the GUI for Wireshark. Okay, we're simply just going to start the capture. But before we start it, make sure you take note of the IP address. Okay, so we just click and enter, and you can see automatically there is listening in on that specific interface. Right. Okay, so we can go back again to our Kali Linux, put in our password, and now we can actually start the attack. So I'll give you a brief introduction to Kali Linux. The Kali Linux is similar to the CyberOps workstation. And I spoke about what the Kali Linux is doing at the installment stage, so you can check out the videos in your toolkit so as not to waste a lot of time, because time is of the essence. We just launched it, and we have the desktop on the left top corner. And we have the icon for the dragon. We click on the icon, and we can see it's a bunch of applications within the Kali Linux pre-installed. Now, this is what I meant earlier in the demo when I said the Kali Linux comes pre-installed. So in this case, we need to start an application, and we need to actually start up a network tool that will help us do some spoofing. Now on Kali Linux, we have the ATT&CK, and you can see there are 2 ATT&CKs now for the purpose of this demonstration. We're going to be using the ATT&CK Graphical. Simply search ATT&CK, and you should get the same results. Simply click on the ATT&CK Graphical, and it's going to open up and ask for a password, because we need to have administrative rights to run the ATT&CK. So we put in our password. And enter. And we can actually see ATT&CK Graphical has started up. So just a note for all of us, you do not need an external USB adapter. You don't need to have an external adapter to carry out this task. The ATT&CK works with the interface on the virtual box. So if you do look closely, we are using the interface with the VirtualBox to do the sniffing. So you don't need an external USB for the demo. We leave everything as default, and we simply just click on the check and agree button. And now you can see ATT&CK actually started, and you can see it is listening on this interface with this MAC address. And you can see this is the MAC address for the Kali Linux. Now we can do a couple of things. We could verify our IP address since we already know the IP address for our Ubuntu. So we're going to verify the IP address for our Kali Linux by simply using the command ifconfig. And we can verify to see that our IP address for this machine is 192.168.56.107. Now we keep that in mind and we can start our spoofing. Okay, the first thing we need to do, if you remember from our last lesson, the first thing you need to do is some reconnaissance. So we need to know we're actually going to be spoofing on our network. And they will scan for all the available hosts, just like we had in our Nmap. But in this case, we're going to be scanning only the devices within our local area network. Now, the ATT&CK graphical does not let you scan outside of the local area network, but only within the local area network. And that's okay. So we simply just click on Scan for Hosts. And you can see this is the scan, and it displays the hosts. And we click on this button, and it will show us all the hosts on this network. And you can see at the moment we have 3 hosts. The first host is basically a gateway of last resort. This is where every packet has been sent through to get out of our network. So we don't need to spoof this host because we would not be able to actually verify the ARP spoofing. And so we took it off our list. And we know this. We don't want to spoof this host because this is not the target host that we want. We already know the IP address of our hosts, so we can take this off. Now, knowing full well the IP address for our Ubuntu is 192.168.56.102, and this is the MAC address. So we can actually make this our target by simply clicking on it and adding the target 1. Or we can simply just click and add target 1. So now we've made this host our target number 1. And we can do a lot of things to the host. So first thing we can do is to start with the ARP poisoning. Now, the ARP poisoning is exactly the same word as ARP spoofing. So we can actually spoof this by just simply clicking on it. And it's going to ask you, do you want to spoof a remote connection? You click on yes. And what it does is it would keep listening for every detail on this network. So whatever this targeted IP address does, we should be able to actually see it. In this case, where we want to actually intercept any passwords on the targeted network, we can do it. But keep in mind, those only work when the host actually goes onto an encrypted web page. And what that means is if the host was to visit an HTTP web page, which is not secured, we should be able to actually see the username and password because the idea is the HTTP uses plain text. Okay, so now we know this, we can go back again. If we were to jump back into our Ubuntu, we could verify if Wireshark is still working and if it's still up and running. Now we're going to open another terminal because we just don't want to terminate our Wireshark. We can actually verify our ARP by typing the word ARP-VN. And you can see something really clearly. Now we can see from our ARP spoofing that we were able to communicate to this machine. So now there's an entry showing that this IP address was connected to a machine. Now, this is the problem with launching an attack. When you do launch an attack, there is always a digital fingerprint left on a system. So with this, I can actually tell, oh, there is a machine on a local area network which is connected to me. So that's no issue. We could do some more damage to the Ubuntu. We simply jump back again to our Kali machine. And we can start doing some things such as a DOS attack, and so on and so forth. So the first thing to do is a DOS attack. We have a couple of options when we click on the MITM menu. It shows us a list of things we can do. So we can see ports. We can spoof a DHCP request. And we can actually stop an attack. So in this case, we want to launch a man-in-the-middle attack now. But how do we do this? Now, if you want to actually stop the attack, you can click on this icon, and that should stop the attack. And you can see the ARP poisoning was stopped. And now at this point, we want to launch a denial of service attack. So how do we do this? Now, if you remember in the lesson, we said attackers usually mark the IP address to look like they were actually from a legitimate source. So we're going to see that in real practical terms. So still on the ATT&CK graphical, we have more options. So we have these 3 dots. There are more options embedded in there. So while on the ATT&CK graphical, we just go into our plugins. On our plugins, you can download new plugins. So what that means is if there are new plugins being created, you can load them onto the ATT&CK graphical, or you can use the pre-existing plugins created within the software. So we're going to be managing a plugin. Okay, going to manage a plugin. You can see we have even more things that we can do. We could send an ARP spoofing. We can send a DNS spoof. We could do a DOS attack. We can do a lot of things. For example, we could do some fingerprinting attacks. In this case, we're going to be launching a DOS attack. Now keep in mind to launch this attack while on the box, this will greatly reduce the ability for me to access my virtual box. But for education purposes, some steps have been put in place to reduce the effect of the DOS attack on my network. But the idea of this is we would be able to see every packet that was being captured on the Wireshark, which makes it easier to understand how the attack actually works. Okay, so now I'm going to choose a DOS attack. And when I click on it, it's going to ask me for the IP address for the victim. So we know the IP address for the victim is going to be our Ubuntu, which has an IP address of 192.168.56.102. Now this is the IP address for our Ubuntu machine, and click Enter. Now it's going to ask us to use an IP address that we want to mask ourselves as. So in this case, we know we don't have any IP addresses called 192.168.56.111, so we use that. Now the idea behind this is the attacker is going to mask his IP address as 192.168.56.111. So whoever goes digging around to see the attack from the victim's perspective, we would be making it much more difficult for them to actually verify that this was the attacker. Because while the attacker is basically spoofing his IP address to look like something different. Okay, so simply click. Okay, and we can actually see the attack has started. Now you can see how this is the fake IP address that we used, and this is the real victim's IP address. And you can see the DOS attack has started already. So, to verify this node before I jump into the Ubuntu machine now, we're going to experience a few issues while carrying out this demo. Now, because we are currently launching an attack on our own Ubuntu machine, so this means the attack would prevent us from actually being able to access our machine. Or rather, to assess our machine. Now I will show you what I mean by that. I will just jump into my Ubuntu machine and I click and enter and try to put in my password. Now notice something. The Ubuntu machine will start to slow down drastically. Now, if I do go back again into the ARP cache and I press the command ARP-VN, now we can see something really funny happened. You see there's an ARP entry showing 192.168.56.11. And we know there is no IP address as such. Now, the easiest way for you to know that this was an attack would be to match the MAC addresses. Now, when you look at this really closely, you can see the MAC address matches, so you know it has to be the same machine. Now, from our lesson, we know that the MAC address on every network device is actually unique. So this means there can't be two devices with the same MAC address. So this means one of the IPs is actually legit and one of the IPs is actually spoofed. The idea behind this is just to show you how it works. Now, I won't really want to launch a real-life attack because that would prevent me from actually showing you how this works in a real-life partner. So, now I'm actually going to stop this attack. So, this has stopped, and I can simply just close the ATT&CK graphical. Now, in the coming lesson, we'll be going through more attacks and more mitigations and things to do to actually prevent these attacks from happening. In upcoming lessons, we'll be playing around a lot with other network tools, so you'll get to become really familiar with them. And you can get to understand how they work and how to prevent them from happening. So we can simply just jump back again to our Ubuntu and go into our home territory and open up the saved packets. And we go into the file. Now, on the file, if you do remember, we saved the packet as arp.pcap. And we can simply just click on this and click on Open with Wireshark. All right, everyone. That wraps up this demo on ARP spoofing. You have your weekly assignment coming up. Remember, it's not compulsory and does not count towards your final mark, but it does help you prepare.